Let's go and modify this process method to make use of a binary reader and a binary writer. So what we're going to do after we've created the input file stream here, we're going to go and create a binary reader instance. When we create a binary reader, we can specify a stream. In this case, it's the input file stream. So now instead of using the file stream directly to read individual bytes, we can use the binary reader to read bytes and convert them to .NET data types. We can also use a binary writer. We do this by creating a BinaryWriter instance and as the constructor parameter, passing in the output file stream. We can now use this binary writer to write .NET data types, which will be converted to their byte representation and output to the file. We no longer need this constant, so I'm just going to remove it. Notice here that we still got this largest byte variable as an int data type. I promised you in the last demo I would explain why this is. It will become evident when we have a look at the output data in just a moment. So we'll keep this as an int variable for the time being, even though it could be a byte. And we're also going to remove this call to the input file stream's read byte method, because we're going to use the binary reader and binary writer instead now, and not the file streams directly. We need to modify the while loop now, and what we want to do is keep looping through the input file until we get to the end of it. To do this, we can access the binary reader's base stream property, which will give us access to the underlying stream of this binary reader instance, in this case the input file stream. We can then examine the position property, which gives us the current position we're at in the stream, and we can say that if the current position is less than the total length of the stream, which we can get from the base stream's length property, then keep looping through the while loop. Let's go and make some changes to the while loop itself. We'll start off by reading the current byte from the binary reader. We can do this by calling the read byte method. There's a whole host of methods on this binary reader instance. Each of these methods will read a number of bytes from the input stream and convert them to the equivalent .NET data type. So for example, we've got read boolean, read char, read double, read single, read string, and so on. But for the moment, because we're reading individual bytes, we're going to stick with the read byte method. If we expected this binary file to contain doubles, for example, instead of calling the read byte method, we would call the read double method. But here we're working with bytes. We now want to write the current byte to the output file, so we'll reference the binary writer instance and we'll call the write method. There's a whole host of overloads of this write method. Each one takes a different .NET data type. So for example here we've got an overload that takes an int, an overload that takes a long, an overload that takes a short, and so on. The data type that we pass to this write method will determine the number of bytes that get output to the data file. In this case, we're just writing out a single byte. We're still going to search for the largest byte, so we'll leave this if statement as it is. But now we can remove this read byte method from the bottom, because the while loop will continue as long as the current position is less than the length of the entire input file. The final thing we're going to do here is modify this line of code. We're not going to reference the output file stream directly. Instead, we're going to use the binary writer, call its write method, which as we just saw takes a number of different .NET data types. We're not going to cast the largest byte int variable to a byte, so this will cause the int overload of the write method to be executed. And that's why I've declared the largest byte variable as an int. So let's go and run this new code. I'm just going to delete the backup complete and processing directories, and once again copy data4.data to the input directory. That's the file processed. Once again we'll come to the complete directory and we'll copy this path, including the unique GUID. And in PowerShell here, we'll paste in this file name and hit enter, and you can see something's different here. We've still got the original 4 bytes from the data file, 05, 0f, ff, and 5e. But notice the largest byte, ff, has actually been written out using 4 individual bytes. That's because we declared the largest variable as type int, and a .NET int takes up 4 bytes. We can see the value 255 or ff in hexadecimal being written here as 4 bytes in little endian byte order. Let's head back to Visual Studio, and we'll just stop this. To fix this, we can just change this data type from int 2 byte. Now when this line of code executes, the write method will be executing the byte overload of the write method, and because a .NET byte data type only takes up 1 byte, only 1 byte will be written to the output file. In this case now, there's not a huge amount of benefit to using a binary reader and writer, as we're working entirely with .NET byte data types anyway. We're not writing out more complex primitive .NET data types such as ints, doubles, strings, so we don't really need the encoding and conversion features that a binary reader and writer provide. Let's run this one last time just to see the output. We'll just delete these 3 folders once again, and once again process data4.data. That's the file processed, and once again we'll go and copy this processed file name and head back to PowerShell and use format hex to take a look at the output bytes. And notice now that the largest byte has been added to the end of the file as a single byte and not 4 bytes.